Everyone, in this lecture we will be discussing some of the questions from these three chapters. Atomic structure, S block, we will be discussing group 1 and alkanes. We will be taking three chapters, three topics, and we will be discussing some of the important questions from these three topics. So let's get started with the very first question. The first one is a question from alkanes. Question number 1 states equimolar mixture of N-propyl bromide and N-butyl bromide are reacted in the presence of dry ethereal solution of sodium. Then, which of the following alkene will not be formed in the mixture? So, in Wood's reaction, the general reaction is Rx plus R dash X plus sodium in the presence of dry ether will give RR plus R dash plus RR dash. So we have to combine two propyl group to get N-hexane. We have to combine two butyl group to get N-octane, and we have to combine the propyl and butyl group to get N-heptane. So these three are produced in the reaction, but N-butane will not be produced. So the answer is option number D. Question number 2. Which of the following carboxylic acids on Kolbe's electrolysis gives alkene as the major product? So alkene is obtained as the major product, and from the previous lectures we have discussed that whenever we have a monocarboxylic acid, that means a compound with one single COOH group, it will give us alkane on Kolb's electrolysis. If we have dicarboxylic acid, that will give us alkene, and if we have dienoic acid, that is going to give us alkyne. So here we have to find which is the dicarboxylic acid. In the given option, butyric acid is a monocarboxylic acid, malonic acid and fumaric acid, both of these are dienoic acid, so they are going to give us alkyne, and succinic acid is the only dicarboxylic acid here, so that is going to give us our desired product, that is alkene. So the answer is option number 2. Question number 3 states which of the following carboxylic acid produces propane on decarboxylation reaction? So if it is decarboxylation, the reactant should contain one carbon greater than the product. So the product is given here to be propane, so the reactant should contain one more carbon greater than propane, and that should be a carboxylic acid as well. That means we need to get a carboxylic acid with 4 carbon, and that is butanoic acid. So the answer is option number A. Next, the following molecule can be prepared by, it is Wurtz-Fittig reaction. Fittig reaction will give us biphenyl, and Wurtz-Fittig reaction is going to give us RR, that is alkene. If we have to produce substituted benzene, then we have to use Wurtz-Fittig reaction. Question number 5, this is the question. So we have to treat the given molecule with Br2. So let us do this. So this is free radical mechanism. So Br2 in the presence of HNO will give us 2 Br free radical, and this molecule also on free radical will undergo homolysis, and as a result of which we will be getting a free radical like this. Now this free radical is going to react with a bromine free radical. Two electrons can form a bond. So a bond is formed between this bromine, and this is the major product. So the answer is option number C. Next question, question number 6. Which of the following halogens is least reactive towards alkene and carries out reversible reaction which is prohibited by the use of HGO or HNO3? So when we talk about the halogenation reaction of alkane, then we have to understand that the order of halogens, the reactivity order of halogens follows the order F2 greater than, Cl2 greater than, Br2 greater than, I2. So I2 is least reactive, and it will carries out reversible reaction. So this will carry out reversible reaction, and this reversible reaction is due to the formation of HI, and that HI is converted to I2 by the use of HGO or HNO3. So here the answer should be option number D. The process of conversion of a bigger hydrocarbon into smaller hydrocarbons is called as pyrolysis or cracking, and it is mainly used in petroleum industry. So the answer is option number D. Question number 8. Normal heptane is treated with Cr2O3 or V2O5. So what is this reaction? The reaction is aromatization. So in aromatization, if we have C6H14, that is hexane, hexane is going to give us benzene, and heptane, that is C7H16, is going to give us toluene. So here the product is toluene because we have normal heptane over here. So this toluene we have to find which is the incorrect statement with respect to toluene. So the product is aromatic, that is correct. Product is cyclic, that is correct, but all the carbon is not sp2 hybridized. This carbon is sp3 hybridized, right? But here it is saying that the compound is cyclic and all carbon are sp2 hybridized, so that is incorrect. So the incorrect option is option number B, and that is the answer. So answer for question number 8 is option number B. Coming to the next question, alkenes and alkanes can be distinguished by. So we have to study the test for unsaturation. And what is the test for unsaturation? Here you can see the most important distinguishing test of this chapter. Br2 in the presence of CCl4 and alkaline KMnO4. This is going to change its color, and this also is going to change its color, right? This will become colorless, and this will, initially it has a brown color, and that is also changed to colorless in the presence of double bond. So these are the tests for unsaturation. So the alkene and alkyne will give positive result, and alkane will give negative result, and tolerance test is given only by terminal alkynes. That means if we have to distinguish between but1 wine and but2 wine, we have to use this test, because but1 wine will give a positive result and but2 wine will give a negative result. So here alkene and alkane are asked, so we have to find which is the test of unsaturation, and first one is, second one is the test for unsaturation. So the answer is option number D. And the last one, they are asking us to carry out the following conversion. What is the reagent required? We have to find the reagent. Here we can see that the reaction is conversion of CO group to CH2 group. This can be carried out by Wolff-Kishner reduction or by This can be carried out either by using Wolff-Kishner reduction or by Clemmensen's reduction. But here we have OH, and this OH is a acid sensitive group. So in the presence of acid sensitive group, we will not use an acid, that is HCl cannot be used. So we cannot use Clemmensen's reduction over here. So we have to use Wolff-Kishner reduction. So the answer is option number B. So this is some of the important questions from alkane section. And now let us talk about the inorganic, where we are going to discuss the questions of group 1 elements. So let's start with the first one. Which of the following is paramagnetic? So when we talk about the oxides of group 1, we have to understand that there are 3 types of oxides. The first one is known as peroxide. Then we have superoxide and also simple oxide. Simple oxide is given by lithium, and that is Li2O. Peroxide is given by sodium, that is Na2O2. And superoxide is given by the higher elements. In that, KO2 is paramagnetic, because if we look at the MOT diagram, we can see that there is unpaired electron present in the pi star orbital. It is present in the pi star orbital. So because of this unpaired electron, it is going to be paramagnetic. So the answer is option number A. Which of the following alkali metal chloride easily forms its dihydrate salt? So that is LiCl. That is a factual question. A student was carrying out a flame test of various group 1 radicals. He found a violet color imparted to the flame. So we have to study the different flame colors. So lithium will give a crimson red color, sodium will give a yellow color, potassium will give violet color, rubidium will give red violet color, and cesium will give us blue color. So potassium will give violet color. So here the answer should be option number C. Question number 4, correct order of mobility. So here we have to discuss something about mobility. Mobility is inversely proportional to size of ions in aqueous state. So here we have to understand some facts. Ionic size, that is size of an ion, is inversely proportional to ionization enthalpy. And we know that hydrated size is inversely proportional to hydration enthalpy. So these 2 points should be very clear. First point is that ionic size is inversely proportional to ionization enthalpy, and hydrated size, that is the size of ions in the aqueous solution, that is inversely proportional to the hydration enthalpy. So from this we can say another relation, that hydration enthalpy is inversely proportional to ionization enthalpy, or we can say that hydrated size is the opposite of ionic size. So if this is the order of ionic size, then this is going to be the order of hydrated size. So the hydrated size means it is again the size of the ion in aqueous medium. So greater the size, lesser is the mobility. So lithium has the greatest size, so it has the least mobility. CS plus has the least hydrated size, so it will have the maximum mobility. So here we have the question. So in the question, we can see that rubidium is given, potassium, sodium and lithium. Lithium has the least mobility. Rubidium among the all have the maximum mobility. So the answer is option number D. Question number 5. Weakest reducing element in alkali metals is. So here we have to study the order. E naught value follows the order lithium, then lithium followed by rubidium, followed by cesium, followed by potassium, and then comes sodium. So you can use a mnemonic for this. Li gayi ruby ki sare kitabem hai na. This is the trick. Li gayi ruby ki sare kitabem hai na. That is the trick for remembering this E naught value. So this E naught value is maximum positive for sodium. Maximum positive means it is more oxidizing, and maximum negative means it is more reducing. So lithium is the best reducing agent and sodium is the best oxidizing or the weakest reducing agent. So it should be option number B. Question number 6. Which among the following is the most soluble in organic solvent? So here we have to talk about solubility. Now solubility is dependent upon covalent character. So here we can discuss this with the help of Fajans rule. Now Fajans rule has many applications. It can be used to explain the covalent nature of a compound, ionic nature of a compound, melting point, boiling point, solubility in water and also in organic solvents. So let us see how this can be used to explain the solubility. Fajans rule states that covalent character depends on 3 factors: large anion, smaller cation and high charge. So first priority should be given for the charge, second priority should be given to the cationic size, and third priority should be given to the anionic size. So in the given options, if you look at the question here, the option contains lithium chloride, lithium bromide, lithium iodide and lithium fluoride. So all have the same cation but the anions are different. Since the anions are different, we have to take the anionic size. So larger the anion, greater is the covalent character. So LiI will have the greatest covalent character, and most covalent character are more soluble in organic compounds, and least covalent are ionic in nature, and those ionic are more soluble in water. So here they have asked for solubility in organic solvent. So lithium iodide, since it has the maximum covalent character, that is going to be maximum soluble in organic solvent. So the answer is option number C. Question number 7. The gas formed at anode of Castor-Kellner cell. So here we will take the cell here. This is the cathode and this is the anode. Let us connect this with the help of battery and a switch. And let us take the solution of NaCl and mercury. So we have NaCl and mercury over here, and we have taken the solution here. So the solution is here. Now in the presence of electric current, the NaCl will dissociate to give Na plus and Cl minus. The Na plus will go to the cathode and Cl minus will go to the anode. This will form Na over here, and this is going to form Cl2 over here, and this Cl2 is moving out as a gas, and this sodium will combine with the mercury present in the solution to form sodium amalgam, and this sodium amalgam on hydrolysis will give us NaOH. So this is the reaction that is happening. So Cl2 gas is liberated in the anode. So they have asked for what is the gas formed, and the gas formed is Cl2. Question number 8. Most acidic hydroxide among group 1 elements is. So again we have a trick for acidity. Acidity depends on 3 factors: oxidation state, electronegativity of the central metal, and it is inversely proportional to electronegativity of the surrounding atom. This should be given the first priority, this should be given the second priority, and this should be given the third priority. So if we give the priority, we can see that here we have LiOH, NaOH, RbOH and CSOH all have the same oxidation state, all have the same surrounding group. So we have to consider the electronegativity of the central metal, and electronegativity, as we know, it will decreases down the group. So lithium has the maximum electronegativity, and maximum electronegativity of the central atom means maximum acidity. So LiOH will be the most acidic. So acidity can be explained on the basis of electronegativity of central atom. So the answer is option number A. Next, let us discuss question number 9. Question number 9 is, which of the following compounds cannot be prepared by Solvay process? And as you know, K2CO3 is soluble in NH4Cl, and as a result of which it cannot be prepared by Solvay process. So that is the answer. And the last question of group 1 elements, which of the following nitrate when heated do not evolve NO2 gas? So we have to categorize the nitrates of S block into two groups. Group 1, where we will take all group 1 elements except lithium. Lithium we will not take over here. And in the second group we will place all the alkaline earth metals, and lithium is also kept over there. Now these compounds, their nitrates will give us MO2, NO2 and O2 on decomposition. And group 1, that is sodium, potassium, rubidium, cesium and francium, they are going to give O2 gas only and metal nitrate. These will give metal oxide and NO2 gas. So here the question is, which of the following nitrate will not evolve NO2 gas? Sodium, as we have seen, it will give us NaNO2 plus O2. So that is the answer. Answer is option number B. So this is all about group 1 elements questions. So let us now talk about the questions of atomic structure. First question, maximum number of electrons in a subshell of an atom with anti-clockwise spin is. So they have asked for maximum number of electrons, and if you could remember, if we are given the values of n and l, then the number of orbitals which is present is 2l plus 1, number of electrons which is present is 2l plus 1 into 2, and this is the total number of electron. Total number of electrons can have clockwise spin and anti-clockwise spin. So the ones with anti-clockwise spin will be half of this, and that will be 12 plus 1. So answer is option number B. The energies E1 and E2 of two radiations are 100 electron volt and 200 electron volt respectively. Then the relation between their wavelengths lambda 1 and lambda 2 is, as we know, E is equal to hc by lambda. So E is inversely proportional to lambda. E1 by E2 is equal to lambda 2 upon lambda 1. So here E1 by E2, if I take the ratio 100 by 200, that is 1 by 2. So lambda 1 is equal to, lambda 2 by lambda 1 is equal to 1 by 2, or lambda 1 is equal to 2 times of lambda 2. So the answer is option number C. Be2 plus is isoelectronic with. So isoelectronic means the ones which have the same number of electrons. Be2 plus have 2 electrons, H plus has 0 electrons, Li2 plus have 1 electron, Na plus have 10 electron, and Li2 plus have 2 electrons. So this 2 and 2 are same. So these are the isoelectronic species. So the answer is option number D. Next question is, what is the orbital angular momentum of p electron? The formula for angular orbital momentum is L into L plus 1 into H cross. That is equal to root of 1 into 1 plus 1 into H cross, and that is equal to root 2 H cross. Option number A. The number of spectral lines in Balmer series when an electron jumps from fourth orbit to second orbit is. So here we have a formula for total number of spectral lines. TSL is equal to N2 minus N1 into N2 minus N1 plus 1 by 2. So we have to substitute the values over here. 4 minus 2 into 4 minus 2 plus 1 by 2. So that is coming out to be 3. So answer is option number B. Next question. According to Bohr's theory, the angular momentum of an electron of fifth orbit is. So according to Bohr's theory, we know that angular momentum is quantized and omega is given by nh upon 2 pi. So here n is equal to 5, so it is 5h by 2 pi, or it is 2.5 h by pi. So the answer is option number B. The notation of an orbital with n is equal to 3, L is equal to 1. It is 3p. Next question. If the radius of mth Bohr orbit of Li2 plus is 70.53 picometer, then calculate the value of m. So Rn has a formula of 52.9 by n square picometer. This is the formula. So this Rn is given out to be 70.53. From here we have to find n square. N square will come out to be 4, and n square will come out to be 9 approximately, and n will come out to be approximately 3. So it should be option number B. Question number 9. Choose the incorrect match. The first one is given to be charge of proton is equal to 1.67 into 10 raised to minus 17 coulomb. That is wrong. It is 1.6 into 10 raised to minus 19 coulomb. Mass of an electron is 9.1 into 10 raised to minus 31. This is correct. Mass of neutron is 1.00867 U. That is also correct. E by m ratio is 1.758 into 10 raised to 11 coulomb per kilogram. That is also correct. So the incorrect option is option number A, and that is the answer. Question number 10. According to Bohr theory, the least energetic photon arises due to which transition? It will be 6 to 5 transition. We can use the formula E is equal to RH into 1 by n1 square minus 1 by n2 square. We have to find the value for every case and compare them, and when we are comparing, we will find that this is the least energetic photon. So the answer for this question is option number A. So with this, we are concluding this discussion of the first DPP. So in the next video, we will be discussing the chapter of mole concept, group 2 elements, and alkenes. So till then, keep learning and stay safe.